Hello, Mr. Hyde, showing you 221 today on intro to limits. So you might have remembered these back in pre-cal, and they're back. They're going to have huge significance for us. So you want to make sure you understand the language of limits. So I made a graph here, f of x. It's a piecewise function of different graphs to help us practice some problems, and I can explain to you limits within these problems to make some sense to you. So say I put the limit as x approaches 3 from the left of f of x. So what that is saying is it's saying as x approaches 3, and that would be like x equals 3 from the left, f of x is approaching, I keep spelling that wrong. So that's kind of how you say it. So the limit is x approaches 3 from the left, and then on the vice versa, if you see a little plus sign afterwards, that is the limit as x is approaching from the right. So from the right, and that is from the left. So if we look at this graph, x equals 3 is right here. There's x equals 3. I'll make a little dotted line here to help you visualize this entire line. So you're saying as you approach from the left, so that means you're on the curve still, and you're coming from the left side. So on the left side, I'm on the curve on this line right here. And as I travel along this curve, where am I approaching? Well, my function f(x), my curve is approaching here, which is 6. So that first one will be 6. As I approach from the right, so now here's 3, and I'm on the right side of 3, and the curve is right here. So as this curve approaches x equals 3 from the right, I'm approaching, my y values are approaching 8. So in that case, that would be 8. Okay? Now for a limit to exist, the limit as x approaches a from the left of f of x has to equal the limit as x approaches a from the right of f of x. Right? And that's what it means for a limit to exist. So say, for example, if I asked you, does the limit as x approaches 3 exist? Well, let's see. The limit as x approaches 3 from the left was 6. As you approach from the left, you're 6. So the limit as x approaches 3 from the left equals 6. The limit as x approaches 3 from the right was 8. And these are not equal, so thus this does not exist. And you can see that from the graph. If the limit were to exist, they would meet up. All right, for a limit to exist, these equal, they would meet up at the same point, All right. It would be like you and me. I don't want you and me. Say you and a friend wanted to meet at Starbucks. Well, you might approach Starbucks from 2 different houses, right? One person's approaching Starbucks from this house, one person's approaching Starbucks from this house. And for the meetup to happen, you have to equal each other, right? You have to both be at that same spot. Right? So that's what it means for a limit to exist. What if to go one step farther looking at this graph, what if I asked you, what's the limit as x approaches 8 from the left? You don't see that. So as we approach 8 from the left, what do we get? So here's 8. As we approach from the left side of 8, we're on the curve here, and we're approaching this y value here, which is 5. The limit as x approaches 8 from the right side of the curve, we're also approaching these y values, the height we're at, is approaching 5. So thus, since these are equal, that implies that the limit as x approaches 8 of f of x equals 5. Right? And that is a little introduction to how limits work, of the left and right, and understand the notation. And for a limit to exist, the left and right have to approach the same value, as we saw in 8. Right? At 8, from the left and right, they both have reached 5. Unlike at 3 they approach different spots. A little bit farther, you would say that at 6, the limit doesn't exist, because from the left, it's approaching 5, and from the right, it's approaching 3. Okay. Hope that all helps. Ask me questions, ask each other questions if you need a little bit of help understanding limits. All right.